Hello everyone. So today we are going to work on, you can see when the car is taking a bend, it kind of turns to right and left. It not smooth. This steering is not smooth. See, even though it adjusts itself with the road, the steering is not as smooth as it can be. So if I turn on slow-mo, you can see that clearly. See, turn a bit and turn a bit to the left, turn a bit to the right. So that's how the car is basically keeping itself aligned with the road. So I'm going to make it smooth by implementing a new function. So with the new function, this is how it works. So this predict path function, this is what we are going to work on today. And here now you should see the car take turns in a much smoother way. You don't see that turn a bit to left, left to right, bit left to right kind of behavior. See, it's smooth. So yeah, so how to make turns smoothly, how to drive steer smoothly, that's what we are going to work on today. All right, so the first thing we need to do is, so this is our current steering function, steering method. It just I have already explained in the first episode, I think, how this steering works. So let's uh, keep it for now, and let's add a new function. Let's call it predict path. So with this, what I am going to do is I'm going to draw a path that the car will go if the car keep the current steering amount. Yeah, if the car keeps the current steering amount, that's it. So yeah, so how can we draw a path? So like, yeah, let me take an example and explain what, let me take an screenshot and explain what I'm trying to do. Let's make the car move to a place like this. Yeah, okay, and let me take a screenshot with this. Right, now this is Photoshop. I'm just trying to explain what I'm going to do. So when the car let me just draw a line to show the path that the car should be following. Let's say the car should take a path like this, doesn't need a fill. Okay, so this is the path the car should be taking, and if the based so this is the car should go. So if based on the current steering amount, let's say let me draw it in a different color. Car is going to go in a path like this. Where is the other one? Let's say the car is going in a path like this. Then, so what car should be doing is, it should turn a bit to the right. So when the car reach maybe a point like this, then again, as the car goes forward, it should continuously keep adjusting its steering level to keep this the predicted path as close to the ideal path the car should be going. So that's the basic idea I want to implement. So how can we implement it in Unreal? Right. So let's first try to draw the predicted path. So for that, actually this is going to be an approximation, not the exact accurate path. So first, let's have a couple of local variables. Hmm, let's get at the location, and let's keep this, promote this to a local variable, current location, or rather start location. Right. And then we need to get velocity. Also promote this to a variable, uh, velocity. Oh wait, that also needs to be a local variable because I'm going to modify those values inside the function. So velocity. What else we are going to need? And then we have this check gap. So this is the distance from the car uh, along the spline that defines the road that we use. This is the distance we use in order to get the point that car is trying to get. So from the car towards the target point, this is the next point that the car this is the distance ideally should be from the car to the next point, to the target point. But since the car is already moving, this can be different from this defined gap. So let's calculate. We already have this target point variable. Let's calculate distance from the car, that means get at the location, to the target point. And if we assume that we are going in this velocity, if I divide this velocity, we need to consider the vector length. If I divide this distance from this vector length, assuming that we are going in a constant speed, we will get the time that it will take for the car to reach from the current position to this target position. So as I said, I'm going to draw a curve, more like an approximated curve. That means this is a continuous curve as far as we can tell, but an approximated curve is more like something like this. Here, start from here, then here. So you can see this is just like a set of line segments. So this is like a approximated curve. That's what I mean by that. So to draw an approximated curve, we need to have segments. So let's divide this by, let's say we need to have I don't know, maybe 5 segments. So let's divide this by 5. So now this gives us the time that it will take to go for the car from for this single segment, one of the segments. So yeah, I'll promote this to another local variable. Let's call it time step. I'm really having a hard time coming up with variable names, so that would be clear enough. Okay, and also we need one other thing. So when the car reach this point, you can see there is a difference in angles. So if the car continue to go this way, it would be like this, but there is a gap. See, so how can we calculate this angle? How can we approximately calculate this angle, not accurately? So I think if we consider the current velocity direction, get uh, let's do it here. Get the velocity, normalize, and get rotation. Now rotation from x vector. This gives us the rotation of the vector that defines the velocity. And if I get that rotation, this gives the current rotation of the car. So if we consider the delta of these two, this gives the difference. Right, now actually, since we are driving, we are only concerned about the rotation around z axis, so up axis. That means this yaw component. So let's promote this also to a variable. Let's call it steer angle. Just let's steer yaw. That's clear. Okay, so now we have the variables that we need. Then let's add the loop. So here, as I used 5, I divided here from 5 because that's the number of line segments I need. So here we should go from first index 0 to last index 4, so that we can have 5 starting, because it is starting from 0. This loop will be called 5 times. And so here I am going to draw 5 lines that approximates the curve. Right, so first let's draw a line. Draw debug line. Is starting from a start location and ends in the start location plus the velocity multiplied by this time step. Let's convert this to a float. Right, now that's the line end. Let's choose some more visible color like this. Duration maybe 10 seconds. Thickness 3. So this will draw one line, start from here to whatever the point that the car will be reaching. And then in the next iteration of the loop, we need to draw the next part. So whatever the result here will be The next is start location. So set start location after drawing that, and the next velocity should be in this direction rather than this direction. So we need to rotate the current velocity, rotate vector around axis. So we are rotating it around z axis because we only consider yaw for steering, and as the angle we can use steer yaw, and this is the new velocity vector. Right, so at the moment I haven't done anything for steering, so let's just see how the car draws these lines, and one more thing. No, this should be enough for now. So to test this, let's do set timer by function name. Function name is predict path. Since this is only for testing, oh wait, why don't we just call it here predict path? Yeah, that should be all right. Let's see. Okay, since it draw a lot of lines, it's not clear whether the car is drawing a curve or just a straight line. So let me disconnect it here and do set timer by function name. Function name is predict path, time every 0.5 second, looping. Right, now let's see. Since the car is going straight, right, is it drawing a curve? Well, yeah, it is drawing a curve. Yeah. See, it's not very clear because the steer angle is very low. But just to test, but I think this amount is okay. But just to test, if I change this to, instead of 5, let's say 20, 19, or if we just make this one 1 and this one 20, that also should be fine. So we should see a more clear curve. See, now you start to see a curve. Hey, see, so as you can see, at this time the car had this type of a curve. Oh wait, don't have enough time to test, so let me make the duration. If I keep this 0, this should be there forever. Oh no, I was wrong. Okay, let's give 100 seconds. That should be enough to talk. Right, now you see, at this point the car has had a steering amount that will lead the car in a path like this. So but the car has adjusted its uh, steering, so that's why it has kept along this path. So yeah, as you can see here, see, now we are seeing, so you can see the path is going this way and this way, this way and this way. That's because the car keep adjusting its rotation. That's why you see this wiggling between in two sides in the car. So to make it smooth, what we can do is, here at the end, let me do another, draw another debug line, draw debug line. Yeah. Here the starting point should be the final final location of the predicted path. That means this is start location again. Start location, and then line end should be the target point. This one also I'll keep 400 seconds and thickness 3. Now we should see, now you see, this is where the car wants to be, but this is where the car will end up if the car keep the current steering amount. See, okay, so now looking at this, you can see if the car has this type of a curve, then what it should do is the car should steer in the opposite direction. And similarly, if the car is going to go in a direction like this, and if the target point is here, the car should be turning its steering counterclockwise. So yeah, now what I'm going to do is I'm going to use this data, this difference, in order to this difference when car is deciding on the steering amount the car should have. So yeah, and also one more thing, you always see some difference between the final location and the predicted path, even if the car is going on a straight line. So I think that should be because I have this check gap, no, gap difference 50 I have used in this steering, in the previous steering method, where if the difference of the predicted location and the location we need to go is less than 50, we just ignore it. I think that's what goes in that gap. So yeah, now what I'm gonna do is I'm gonna disconnect this from here, and maybe for performance purposes, let's reduce this to something like 5. Here also 5, and let me connect it here just to see how it works. You can ignore this initial because we don't have values initially, that's why. Okay, now yeah, things are working. All right, now let's disconnect this steering part, and here let's add a steering method. So how do we add a steering here? So we need to check if the car is whether to steer to the right side or to the left side. So here, how do we calculate it? So we have the final location as the start location. Yeah, I know that's a bit confusing, so maybe we should change this. The name, let's call it predicted location. Okay, so we can get the predicted location and get the location which gives us the current location of the car. And if we do a find look at rotation from the car to the predicted location, we should get a rotation. Similarly, if we do another find look at rotation from the car to this whatever the target point, that also gives us a rotation. And if we do a delta here, and split this, we can get a yaw. So if the yaw is positive, we should yeah, if the yaw is positive, that means it's a situation like where car is going here, but we need to give a steering counterclockwise. Anyway, it's easier to test and see, so that means I think we have to multiply this here. But in for this we can have values like 30, 90 from 0, and also from 0 like minus 30, minus 90, values like this. So just to be on safe side, let's multiply this with, I don't know, let's try -1 first, and then let's clamp this in between -1 and +1, and let's set steer mount. This is a variable that I had set before, created before, and steer, let's call the steer function with this value. We could just directly put it here, but just in case we need to do some maybe lerping or anything, let's use the variable first and see how it works. Did I disconnect the previous steering method? Yes, I did. Alright, now let's see. Yeah, now the car seems to be going in a much smoother steering than before. And yeah, it is keeping to the destined location. It's going in the correct path also. If I do this slow-mo 0.2, wait, slow-mo I think 0.2, we can slow down the car and see what's going on. See, car is coming in a much smooth steering compared to before. See, this is a nice curve. Alright, so yeah, that's it. And one more thing, it would be better if we can further reduce this the number of segments just to reduce the calculations. But that depends on how many cars in the world you're going to put, and so I think this should work fine, the value. So shall we try this in the big map? Oh, I think these debug lines can cause a problem. Let me disable those. They were only for, oh wait, they are only there for us to debug. So let me disconnect them like this. If you want, you can re-enable them and see what happens. Okay, yeah, they are going pretty nicely. Nice. They are going in a very nice curve. They don't wiggle into sides like before. Alright, so with this, I'm gonna stop this episode right here. And maybe next time I want to work on like maybe overtaking or like further improvements to their speed control, where like you see initially when the cars getting started and put them on the road, they somewhat runs into collisions, but even though they run into collisions they can eventually recover and continue going. But I want to do some further improvements to that behavior also. So yeah, actually I have a lot of things in mind, like implementing cross sections of the roads, traffic lights, all those sort of things. So yeah, let's see what we can do in the future. And thanks for watching. So as always, project files will be available here in the Patreon page for the download. Link would be in the description below. And if you like to support my work, you can get the membership of the Patreon club. And feel free to comment and suggest further additions or new features that you would like to add into this system in the comments below. See you in another episode. Goodbye.